Okay, so this the DC motor. Okay, DC motor, and this principle, this the battery, this battery or any source to just transfer this stick. Then this the uh, electrical flux convert. Then the through this magnetic part, north and south pole. This the uh, throw, and this portion is rotation. Okay, so this is the main mechanism of DC motor, and I will submit your DC motor construction and mechanism your Facebook group this day. Okay, we'll check this.
Yes. Okay.
Okay. So this today just a simple part or uh, DC motor. You know that our generator and motor just main platform. This the generate. If this current flow upper part, this is the generator, and motor just change. This is the current flow incoming, current incoming, and more generator outgoing, because this is the generation complete, then the throw, and this motor, this is the supply, this is the supply to, suppose this is the series motor, so this like this. Okay, plus minus is the DC.
Sir, the generator is the creator of the source, right? Like current source.
Yes, but
While the motor, yeah,
motor not create the current source. This is the source to
yeah,
throw this part.
It
Then
from
this
the
part
supply.
is rotation.
وكانت consumption.
This part is rotation, but but this mechanism almost same. Generator and motor mechanism almost same. Internal mechanism same. Okay, so if this part is rotation, motor is this part, this is the motor. So if the current flow this line, then this part is what? This part is rotation. If this part is rotate, then must be this section is generation, because if generator this part is rotation, then this is the generation. So also same part, this is the motor part and generator part, mechanism same. Okay, this is the mechanism same. So if the current flow this section, then this part is rotation. If this part is rotation, must be this part is power developed. Okay, and current flow back part. This called back EMF. This called EB, developed voltage. Okay, clear? Motor developed voltage called back EMF, and the generator developed voltage called generated voltage. Okay, what's the back? Why the back? This the current flow, this part. Okay, current flow, then this part is rotation, then this part, if this part is rotation, then this part is power developed, because this part is armature and including, then this part, whole mechanism, generator mechanism and motor mechanism part is same, so must be this part is power developed. Okay, this developed power IA is EB, and this developed power IA is E. Okay, E is equal to VI, so EGIA, and this power But this the back EMF. Back EMF means this. Wait, just show. This back EMF is very, very important. Okay, this is the back EMF. Okay, this part, this is the voltage. This voltage through this part, current flow. This part, if current flow, then this part is active. This is the rotation. If this part is rotation, and then this part is generation part active. This because this is the electrical field available. So must be some voltage or some power developed this section. This developed power must be through this line, but this not possible because this is the power supply. So now this part is not this back EMF called load in this section. You know that our electrical circuit. Sorry. You know that our electrical circuit part. Suppose this the different source. This one source. This the one distance. This another. Sorry, this the one distance. This another source. Okay, so this suppose R1, R2, and R3, and this your current flow I. Can you hear me?
Yes, sir.
Yes, sir.
This is the E1 and this is the E2. If one circuit and two sources, E1 and E2 sources, so your voltage law, Kirchhoff voltage law, you know that these all are current I. So this is the current flow minus 0.2 plus. So this is the I1 positive, then E1 positive, then minus this resistance IR1 plus this minus this resistance IR2 minus this resistance IR3, and this current flow, this is the positive to negative, so this is the plus, this is the minus. This load, this resistance is minus, this voltage is minus E2 is equal to 0. You know that this equation?
Yes, sir. This is KVL.
But caveat. But this voltage source, if voltage source change, then this is the plus. Okay.
Yeah. Whenever you change the direction, the
This
the
voltage,
signs will be yes.
yes. This is the minus, then this is the plus. This voltage and this voltage both are plus through the minus part. If this throw this part is plus part and this the minus, then this the minus. This voltage, now this voltage is not minus this voltage. Suppose this is the 500 volt and this is the 100 volt. So this part is, this voltage is must be minus. So this is the voltage source 400 volt this circuit. Okay, and another source also. Okay, this all are load, this load, this load, this load. Now this part is, if current flow, this part is positive, then now this is the load. Okay, in this case, our circuit, our motor circuit, this our motor. Okay, and this current flow, but EB, this is the voltage back generation, then the back EB and IA, this also RA. Okay, and suppose no need the resistance, suppose this is the supply plus and minus. This is the V. So this V and EB, this EB, now this EB is current flow reverse portion. So reverse portion means this, now this the minus. Clear? This source, this our total source. So total source V minus this part IARA, and also this part is minus E is equal to 0. These are clear? Suppose this your resistance and this part plus minus okay. So current flow this was EB and this RA. This total current same IARA or I do the series, so current same. Suppose these are I. So this circuit, if this the V is source, this the positive V, then this all loaded is minus IARA, and this the current flow. So now this portion, if is the positive, so current flow this part. Okay. This minus this plus. Sorry, this is the positive too. So this part is minus EV is equal to 0. All are clear? All are clear this?
Sir,
Yes.
intuu qoray way daada.
قاعدة قريت كلير كديك ده شيء
Formulada.
Current flow, this part is flow. Okay, current flow. And this is the negative to positive. Then this is the positive. Then this is the resistive. All resistive, this is the load. All load is minus. So this is the minus. And this is the positive to negative. So this is the minus. Now this is the minus. If this is the minus to plus, then this is the positive. But our current, this current flow, this is the minus to plus current flow. Our current flow, this part is current flow, this, and this part also current flow, this. So both are one flow this and another flow this. This is the V. This part is V and this part is V. Okay. So this is the positive and this is the negative. Okay. Clear?
Okay, sir. Yes, sir. Sir, one interesting question is, see the DC motor.
Yes.
You said the DC motor is not the create the current. So how about if we rotate, the direction of the DC motor? Is it possible?
DC motor, just if you change the voltage source, then direction motor direction change.
No, sir. Look it. I'm talking about.
I not understand your question.
Okay. I'm talking about in here, sir. So this is the this is the voltage that we applied to the DC motor. So and we know that the direction of the current is going in this direction. So if the direction, if the current direction is in here, so how about if we rotate the DC, the DC motor, if we rotate the direction of DC motor, is it possible?
Yes. Okay. Just listen. Um, this your motor. Okay. Our main
Okay.
motor mechanism. If DC, this the power supply must be DC power supply. This not AC.
Okay.
Okay.
Yes. Yes.
Power
Yes.
supply, DC power supply. So DC power supply, this is the positive fixed and this is the negative fixed. This is the armature rotation, this is the brush, positive brush, and this is the negative brush. Okay. Then armature brush, this if this positive voltage, then this rotation circle this. If this rotation circle, then if, why the rotation? Our mechanism is the drawing. Drawing our current flow, this the ion, just 1 minute, one picture or one video I will share. Okay, this is not possible drawing. Wait 1 minute.
Okay. Sir.
Okay, sir.
Current will start to flow. As we see positive terminal of the battery is connected to left conductor of return, and negative terminal is connected to right conductor of return. As we see in the model, north pole of the magnet is placed near left side, and south pole is placed near right side of the terminal.
Hello.
Yes, sir.
Yes, sir. Can you hear this sound? Another extra sound, my PC sound.
Yes, sir. Yes, sir.
Okay. Now
Yes, sir.
share this thing. Okay. Now check this. Look this. Okay.
Okay, done.
This is the motor. Okay.
Order is very simple. We can see that when the current conductor is placed in magnetic field, it experiences some force in particularly direction. The very basic construction of a DC motor contains a current carrying armature, which is connected to the supply through commutator segments and brushes. The armature is placed between north and south pole of a permeate or an electromagnet. In elementary model, one single turn of conductor is placed between two opposite poles. If we start to supply DC via commutator system, current will start to flow. As we see, positive terminal of the battery is connected to left conductor of a turn, and negative terminal is connected to right conductor of a turn. As we see in model, north pole of the magnet is placed near left side, and south pole is placed near right side of the turn. Current in left side flows inward, and current in right side flows outward. As we see, conductor is carrying current and they placed in magnetic field. Both of them experience the mechanical force acted on them. Direction of mechanical force can be easily determined by applying Fleming's left hand rule. To do this, spread out your left thumb, forefinger, and second finger so they are all at 90 degrees to one another. With that, if the forefinger is aligned along the direction of magnetic field from the north pole to the south pole, and the second finger is aligned along direction of the current and left side conductor, then thumb indicates direction of mechanical force.
This is the magnetic field, and this is the electrical
Similarly,
current flow.
if the forefinger is aligned along the direction of magnetic field from the north pole to the south pole, and second finger is aligned along direction of the current and right side conductor, then thumb indicates direction of mechanical force. Due to this upward and downward forces on the turn, one torque is produced when turn rotates on clockwise direction as shown. After rotation of the turn comes to vertical position in respect of the magnetic field. At this position, there is no current in conductor because turn, conductor, and brushes rest between two commutators. Hence, there is no force acting on conductor by due to movement of inertia. Turn continues to rotate and comes horizontal again. Position of conductor has been changed here. That means conductor, which was previously in left position, comes to right position, and which was previously in right position comes to left position. At that position, we can determine mechanical force with applying Fleming's left hand rule. Let's do that. To do this, spread out your left thumb, forefinger, and second finger so they are all at 90 degrees to one to another. So if forefinger is aligned in direction of magnetic field, that is, from north pole to south pole, and second finger is aligned in direction of a current in the left side conductor, then thumb indicates direction of mechanical force. This is clearly upward here. So if forefinger is aligned in direction of magnetic field, that is, from north pole to south pole, and second finger is aligned in direction of the current in the right side conductor, then thumb indicates direction of mechanical force. This is clearly downward here. Do this upward and downward forces tend to rotate in clockwise direction. From that explanation, we can come to the conclusion that here in this model, we can see that whichever conductor comes near south pole experience upward mechanical force, and near north pole downward mechanical force. And due to this continuously forces, mechanical turn rotate, even if battery is not connected. particularly DC motor, rotates at the same principle like this elementary model. Instead of single turn in DC motor, we have mountain turns on major coil. And instead of 2 poles, there is number of poles installed. I hope that you like it.
Okay, all are clear?
Now, we are going to mechanical force towards a particular direction. Let's
This
take
is
a
the part.
simple elementary model of a DC motor. Is placed in
This is the part. Okay, this is the force. Our current, not pole to south pole, our flux directly not connect.
side a magnetic
This is the fact. This not directly. This the if this the our instrument, this the conductor, this conductor to if this conductor present,
field, it
this our force is not direct hit this point to this point. This the throw this the point. Okay, this point current a flux through this point, then this the some rotation, then the through this point, then rotation, then through this point, this the rotation. This is the multiple point. Okay, throw point. If the flux throw, then this part is rotate, then flux just passing this north to south. Okay, this is the any slot. Okay, throw slot, flux throw slot. Okay, this part, then this part just throw this point.
experiences mechanical force towards a particular direction. Let's take a simple elementary model of a DC motor. In this model, one single turn of conductor is placed between 2 opposite poles, that is North Pole and South Pole as shown here. Now, if we start supplying DC through a commutator system to the single turn, current starts flowing through it. At that position, as we see, the positive terminal of the battery is connected with left conductor of the turn, and negative terminal of the battery is connected with right conductor of the turn. Moreover, we see here in the model, the south pole of the magnet is placed at left side and north pole of the is placed at right side. Current in this left side conductor flows inward, and current in right side conductor of the turn flows outward. As we see, the conductors are carrying current and inside the magnetic field. Both of them experience mechanical force acting on them. The direction of the mechanical force can easily be determined by applying Fleming's left-hand rule. For that, we have to stretch forefinger, second finger, and thumb of our left hand at right angle to one another. With that, if the forefinger is aligned along the direction of magnetic field, that is from North Pole to South Pole, and second finger or middle finger is aligned along the direction of current in the left side conductor, then thumb indicates the direction of mechanical force. This is clearly upward here. Similarly, again, if forefinger is aligned along the direction of magnetic field, that is from North Pole to South Pole, and second finger or middle finger is aligned along the direction of current in the right side conductor, then thumb indicates the direction of mechanical force. This is clearly downward here. Due to these upward and downward forces in the turn, one torque is produced, which tends to rotate the turn in clockwise direction as shown. After clockwise rotation of 90 degrees, the turn comes to a vertical position in respect of the magnetic field. At that position, there is no current in the conductors of the turn, as the conductor end brushes rest in between 2 commutator segments. Hence, there is no force acting on the conductors, but due to moment of inertia, the turn continues to rotate and comes horizontal again. But position of the conductors has been interchanged here. That means the conductor which was previously at left position comes to right position, and which was previously at right position comes to left position. At that position, again mechanical force acts on the conductors, whose direction can again be determined by applying same Fleming's left-hand rule. Let's do that. For that, again, we have to stress the forefinger, second finger, and thumb of our left hand at right angle to one another. With that, if forefinger is aligned along the direction of magnetic field, that is from North Pole to South Pole, and second finger or middle finger is aligned along the direction of current in the left side conductor, then thumb indicates the direction of mechanical force. This is clearly upward here. Similarly, again, if forefinger is aligned along the direction of magnetic field, that is from North Pole to South Pole, and second finger or middle finger is aligned along the direction of current in the right side conductor, then thumb indicates the direction of mechanical force. This is clearly downward here. Due to these upward and downward forces, the turn tends to rotate in clockwise direction as shown. Now, from that explanation, we can come to the conclusion that here in this model, whichever conductor comes under South Pole experiences an upward mechanical force, and whichever conductor comes under North Pole experiences a downward mechanical force. And due to these two forces, the single turn continues to rotate until the battery is disconnected. A practical DC motor rotates with same principle as of this elementary single turn model. Practically, in a DC motor, in place of single turn, there is multi-turns armature coil, and in place of two poles, there may be more than two, even number of poles. Hope you understood. Thank you. Grammarly does more than catch errors. With Grammarly, you can find really good, no, perfect words that make your writing sharp, or explicit, or excellent, or distinctive. As a matter of fact,
So, Amir? Hello?
Yes,
Can you hear me?
yes, sir.
This clear the motor part, and now this part, there is the main things. This our North Pole, okay, and this the South Pole, okay, and this your commutator part, okay, this the commutator part. Just 1 minute. Just cancel this here, okay.
حزب مركب ما حبيبي
ما شاء الله انا بوصل توس عايش الدكتور مانيس
وهذا ما تنو إيش الضغط واسعه توسكا وبعدين مودو وقلبه
يعني كان سامع حيسينا لو قلت
اللي هو
أهرا
حتى خدت انا قلت حتى قلنا انا
حيزيد
هو خبر
حيزيد سكيب
حيسيب حتى انا داوي سنه
حيزيد
اسكيبا
سكيب
لو
هتعمل له سكيب هتعمل له قص نضر دنيو
أنا ويا وعايز تاني ومحانا معلق وعلى كذا حيسينا ونوضح
حيسيب والله انا داوي حتى ومعنى كان انا قاعد بقى
لكن والله ست مارتن جو هذا مارتن أسامي تزل إسكات كي بسني عشان يتوم واي جبت تونسيكي عشان يتوم بروبلم إسكو حالي توم بندس كويستا
انت احمر صحوا ادرسوا
مرمود مع مردي زي
ما ينصحوا مش خلص انا هنا
ما مودو قريب اسكام شيء ورا بوتنو
أبوزو
معني قاو عاملينها وانت غناي حيز مرقصوقل مار حيز مرقصوقل مارتا فارتو عندنا جرجرة مارتا بردو عص وصو ديار سدانو
معناه ورقة جرتهم يعني
بردو جرجرنا بسشا
جعيلو
وصو دلعة كدي وصلانا عندنا
حيسيس كنا قلت ترى يا انت
أيوة على كده
ولا اسكجفا ورا مرقي
هلو
معني كيميا مزي معني كيميا واحد زندوي
ادرسوا
بص
ورنيو معنا قدام حوك شيكينا انا خدك انا نحنيو مره وكبحويا وبسول ابنو وكبحويا
انا حتى اساس والله كاد الحمد لله انا معاني كني بوس وقال لي انا
خدك
موتور دي سي موتور وكان لي نو
لا تاسمع مره بونص iyo wax sheekina tee max iyo
maya horta macalinku wuxuu dhahay maxaa dhahay assignment on dirsoma oo 15 problem from chapter 26 mid kale tahay فاهموا زي
10 حب maan soo qoraa
15 xabo dhahay chapter 26 ka soo shaqeey adigoon qofka koobiyin laakiin buugo caadi waa ka koobiyin kartaa laakiin qof kale ka koobiyin
buug asal ma nasiinay aywa
chapter 26 am gudahay chapter 26 am gudahay marka wuxuu dhahay waxa kale jiro dhahay macallin xiisaan la soo dhaaf fashilo kan hadda maxaa lahaye exam ku shaqeey mid kale maxaa lahaye taskigan idin ka shaqeeya ninkii ka shaqeynay bonus ma kasoo hadda
hello
yes sir
so this the fact these the north pole and this the south pole and this your armature part. Okay, what this the part is rotate because this magnetic flux this the throw, you know that magnetic flux is throw north pole to south pole. Okay, north pole to south pole throw, but this is the point. This point is not directly throw this north to south pole. This is the at first this point this magnetic flux will throw this part. Okay, then this part is rotate, then magnetic flux is turn this part to this. Okay, all magnetic flux does the rotate this. Okay, so if the throw this point, then this point is rotate, then throw this point is rotate. So this is the mechanism magnetic. This is the armature rotation mechanism. Okay, yeah. I also another video send your Facebook group. Okay, this day, and then you clear this part. So this is the flux rotation and our armature rotation. Now, if armature rotation, you know that our generator part, extra prime mover or extra fuel will throw, then our generator part is rotate. If generator rotate, then this the power develop. Okay, so in this same case, this is the DC part. So DC part, this part is at first current flow. This is the portion. Then this part is moving. This part is moving. Then and this part is also power develop. This is the motor, but this is the what is generator power develop. Okay, this power develop are and flow anti-side. If the anti-side, then our equation is minus. Okay. This developed, then throw this side. So now this is the positive, but this is not possible. This throw, this is the empty side. Okay, can throw empty side. So this is the minus EB, back EMF. This is the main fact of motor. Okay, back EMF. Clear? So,
Yes, sir.
so this day we are just simple work our simple work. This is the back EMF and this is the mechanism of our armature rotation. Okay, armature rotation mechanism or motor rotation. Okay, there. So in this part. Okay, yeah. So motor principle.
Yes.
So this day your topics motor principle and motor back EMF. Okay, motor principle and back EMF of DC motor. Okay. So today our class not continue. Today our class is finished. Okay. Next day.
Okay, sir. Thank you.
We are this part. Okay.
odayga saxa macalinka maarta ku adkaysa 10 inuu soo boodgaraynayo.
Sir, you horta janalkiis ma haysaa saxaabo?
I'm sorry.
Janaalkiis waa hayaa laakiin dee
Cashirka koow ku jira. Sir, we need the recording videos. So you did not upload.
This day must be uploaded. Okay.
Okay, sir. Okay. Idris oo kusoo share group kusoo share maanta soo dhigaa oo group kusoo share janalka ardayda kala ka faa'iideystaan.
So just present.
Okay, sir.
So upload grade anyway.
Date 16. Okay. Goal 7. 29 by 1.1. Six. 30.6. These days, first class, 31.6. Another display. Only 1, 2, 3. One, two, three, four, five, six, seven, 8, 9, 10, 11, 12. 12%. I mean,
Yes, sir.
today only 12% present.
How many?
12.
12. Yes, sir. Even the previous class was presented 12 students. Today, you know, ceremony madam class, 12 students was presented. Only 12.
Okay, so
Yes, sir.
today subject all video.
Okay. Não estou subindo nada na vídeo.
Thank you very much.
Se dei dá, porque posso.